Welcome to all of you. Today we'll discuss the topic that method of separation of mixture. Different methods, different techniques are used to separate different components of mixture. These are separation using magnets, that is magnetic separation, evaporation, filtration, centrifugation, separating funnel, sublimation, chromatography, distillation, and fractional distillation. So these are the very important methods to separate physically different components from the mixture. Let us discuss one by one. Separation using magnet, that is magnetic separation. If you take a mixture of sand and iron powder, how can you separate it? It can be separated easily using magnet, because magnet attracts the iron powder so that it will be separated from the sand and iron filling mixture. So here the principle is that the magnetic substance is separated from non-magnetic substance from the mixture using magnet. So here iron is a magnetic substance and the sand is non-magnetic. So using magnet we can separate iron fillings, that is iron dust, from the sand and iron mixture. So this is the important method for separation of iron dust from the sand and or any kind of mixture containing iron fillings. Next method is evaporation. We know evaporation is the technique to vaporize the solvent particle from the solution, keeping the non-volatile soluble solid in the mixture, in the solution. So in this method, the volatile solvent will be separated from the solution by evaporation methods. That means by heating, by boiling the solution, the solvent will be removed as vapors and keeping the non-volatile solute in the solution. When all the solvent will be evaporated, then the solute will be remain at a residue at the bottom of the container. So this is a very important technique to separate salt that from the solution, sugar from the solution, water solution. You see the diagram here. Here the basin that is evaporating dish and containing solution. When the solution will be heated by Bunsen burner, then the solvent, volatile solvent, will be easily evaporated. Then the remaining solute will be obtained at the container. So in this way we can separate the soluble component from the solution by evaporation methods. Then third method, that is filtration. Very easy technique. The principle of this method is to separate the insoluble components from the soluble mixture. Here we have to use filter paper. Through the filter paper, the small particle can pass, but the larger particle cannot pass. In this method, that the filter paper that allow the solution, that is called filtrate, and the substance which remain on the filter paper is called a residue. So generally during filtration, two things will be separated. One is filtrate, another residue. Filtrate will pass through the filter paper and the residue cannot, so it remains on the filter paper. So you can separate sand from the sand water solution, that chalk powder from water solution, like this. Because the chalk powder and sand have larger size, it cannot pass through filter paper, so it remains on the filter paper. Then centrifugation. Centrifugation is very important technique to separate the heavier particle from the lighter particles. So in this technique, the solution will be taken in the centrifuge machine. The centrifuge machine will allow the solution to rotate at high speed. When it will spun rapidly, then the denser particle, the heavier particle are forced to the bottom, and the lighter particles stay at the top. So the lighter particle remain at the upper layer and heavier particle goes to the bottom. So the example is separation of plasma, RBC, WBC from the blood using centrifuge machine. So plasma is lighter, it remains at the upper layer, and RBC is the heavier, remains at the bottom layer. And in between the plasma and RBC, the middle particles, that is some lighter particle, that is WBC and platelets, remain at the middle. So in this way we can separate that RBC from the blood, and separation of plasma and RBC from the blood. So this is called centrifugation, where the principle is to separate the heavier particle, denser particle from the solution, keeping the denser particle at the bottom and lighter particle at the top. The next method is separating funnel. In this apparatus, the insoluble two or more immiscible liquid will be taken. That lighter liquid will be remain at the upper layer, and the heavier liquid remain at the bottom layer. So in this method, we can separate the liquid on the basis of their density. The lighter will be at the upper layer and heavier at the bottom layer. Suppose to separate oil and water mixture using separate. Suppose oil is lighter, it will remain at the upper layer and water will be bottom layer. So from the bottom, when you open the stop cup, then water will goes out, then keeping kerosene in the separating funnel. So in this way we can separate different immiscible liquids from the mixture. Then sublimation. We know sublimation is a very important method to separate the volatile component which is easily vaporized without attaining liquid state. That is called sublimation. But when it will be heated, then the vapors produced will be produced as sublimate, then keeping the non-volatile substance in the container. So for you see the diagram here, the mixture of volatile, suppose ammonium chloride, all ammonium salt is volatile, ammonium salt and other substance, non-volatile substance taken in the China dish. Then the substance is covered with a funnel, glass funnel. Then the top of the funnel is plugged with the cotton. Then when the substance will heated, then the vapor of the ammonium chloride produced gets condensed at the upper part of the funnel. These are called sublimate. And the insoluble, that non-volatile substance, remain at the China dish. So in this way we can separate the volatile component from non-volatile component by heating. So this method is called sublimation. So in this method, the volatile component will be separated first. Then chromatography. This technique is very important technique to separate different color pigments, dyes and natural colors, drugs from blood. We can separate by this technique. Here during the separation, the components will be adsorbed on the stationary phase in the different way. On the basis of their adsorption capacity, they will be adsorbed on the chromatography paper. When that is called stationary phase. So here mobile phase are the components which will be separated, and stationary phase is your paper. On the paper, the different components will be adsorbed, and the adsorption, the nature of adsorption depends upon the nature of substance taken. So you see the diagram. In this diagram you see here green, blue and red color mixture is taken in the paper at the bottom of the paper. When the paper will touch to the solvent, then solvent move along with the different components. So on the basis of their adsorption capacity, they will be separated. You see the green color, as that is adsorption capacity is very less, so it moves faster than compared to blue and red. Red capacity is very less adsorption. The adsorption of red color on the paper is very less, that's why it remains at the bottom, and which is Absorption, it is absorbs very fast, that the red color absorbs more, that's why it cannot move on the paper, and the green color the absorption is very less, that's why it move faster. So on the basis of their absorption capacity on the stationary phase, it will be separated and it will be obtained in different colors. That's why it is called chromatography. The different components can be characterized, can be identified in different colors. So this method is used to identify and to separate very small amount of components in the mixture. Then distillation. In this technique, in this method, two or more miscible liquids whose boiling point difference is very less, that is how much, more than 25 K. This method is used when the boiling point difference between the components of liquid is greater than 25 Kelvin. Due to high boiling point difference, they will be separated easily. You see the diagram here, it is a distillation flask. The mixture will take in the distillation flask, and the distillation flask is connected to the condenser where the vapor will pass through it. Then when the mixture will be heated, the low boiling substance will produce fast vapor. The vapor will pass through condenser. The condenser contain the water, and the water will pass through the inlet and it pass through outlet. When the water remains in the condenser, the vapor produced will be condensed and it will be separated in the form of liquid again. So first the liquid will evaporated into vapor form, then vapor again condensed to liquid form. So that's what is called distillation. In this method, the liquid will be separated on the basis of their boiling point. The liquid which has a low boiling point will be separated first compared to the higher boiling point. You can separate alcohol from water. Alcohol has low boiling point compared to water, so when the mixture will heated, then alcohol will be separated from the solution coming first compared to water. So this method, the principle is that they should have higher boiling point difference, that is more than 25 K. Then it will be easily separated. This is called distillation. Then fractional distillation. Fractional distillation is the method to separate different components in different fraction on the basis of their boiling point, but the main thing is their boiling point difference should not be greater than 25 K. It should not be greater than 25 Kelvin. So when the mixture of liquid will heated, then at the different fraction it will be collected. You see it is a fractionating tower containing petroleum. Petroleum contains different types of liquid, different components like kerosene, petrol, diesel and naphthalene, that is LPG. So many different hydrocarbons present in the petroleum. When the petroleum will be heated at the different fraction, different components get separated in the different fraction. So their boiling point is very less difference compared to the when the boiling point difference will be very less, then it will be separated by fractional distillation. But when the temperature, the boiling point difference is much more, then it can be separated by distillation. So this is the difference between distillation and fractional distillation. Fractional distillation is applicable when the boiling point difference is very less, that is less than 25 K. When the boiling point difference is much more, then we can use only simple distillation. So by this way we can separate different liquid components from the mixture using fractional distillation method. So you see the petroleum, when it will be undergo fractional distillation, it will produce refinery gas, LPG gas at the top, then petrol, then naphtha, then kerosene, then diesel, like this. So many components will be separated on the basis of boiling point. The liquid which has a higher boiling point will be separated at the bottom, and the liquid which has a lower boiling point will be separated at the top. So this is the principle of fractional distillation. Then that is separation of components of air. We know air is a mixture of generally carbon dioxide, nitrogen, oxygen and other different gases. So it will be separated by liquefaction techniques. Liquefaction is the method of condensing the air into liquid form. Here you see how it is done. Here the all air mixture will be taken in the chamber where high pressure is maintained. When it will be compressed using compressor, then the air will be hot. Then the hot air will be allowed to pass to the chamber where cold water is flown. When the cold water will flow, then the hot air will be condensed, and the condensed air again pass to the another chamber. In the chamber, when it will be separated, first carbon dioxide will be separated in the form of dry ice, as it has low compared to this. It is first it will be separated because the boiling point is compared to this, it is high, so it will be first separated. Then it will be cooled first. Then the remaining mixture will pass through the another chamber, then through the jet. When it will be allowed to pass through the jet, then the mixture containing nitrogen, argon will be separated. Nitrogen will be separated at the upper layer and argon will separate the middle layer. The remaining last part, that is oxygen, will be separated in the last at the bottom of the tower. So in this way we can separate different components from the air. The method is liquefaction. So these are the flow chart for the separation of different components of air. The method is called liquefaction, that is condensation method. Okay, this is about the different methods, different techniques to separate the different components of the mixture. Generally the all methods are physical method. No method used to separate the components that chemically. The physical methods are used to separate the components from the mixture. Okay, thank you all.